Hello. Today I'll be taking you through a customer's journey migrating DB2 HADR clusters to AWS. This was a very challenging project. We had three large global applications to move to AWS. We had 8 months to do about 50 servers, I would say, 50 DB2 clusters. And they were all global in nature, and so it took a lot of coordination to migrate these systems in other parts of the world. So this specific video is for stage one, which is where 75% of the project time was spent in. And a lot of times customers don't like that 75% of the time is being spent in dev, but this is really where the foundation was laid, and a lot of effort was used to automate all of the processes that needed to be done to deploy and migrate as fast as possible. But we needed to take this time to make sure we had it right and test it properly. So step one was your initial step where you're learning about your environments, and you're essentially doing your technological deep dive and making sure you understand these systems well enough to migrate them to AWS and AWS resources that are well-fitting. It's also a time to understand the processes that they are running on these systems. Absolutely anything that you think you would need. They had a lot of cron jobs that they were running, and those needed to be migrated over. They had numerous files that were used to help the team administer these databases, so that needed to be migrated over. Stage one, or step one, is really the time to understand your systems, learn about how many, where they are located, resource consumption, and things like that. Step two is developing your migration plan. It doesn't have to be super detailed, but you got to lay out the steps on how you're going to do it. This customer wanted a live migration, meaning they couldn't afford any downtime when it came to production. And so I insisted that we migrate dev, QAT, UAT, and all the environments in the same manner as we would do it for production, in order to just instill a proper procedure, and make sure we follow each rules, make sure all the team members are know the steps to take and have gone through them before. And so since they wanted a live migration, the plan I created was to set up HADR on-premise with a standby server in AWS. Have it synced up, have them communicating, have the primary communicating changes to the standby within AWS. And for migration day, we would prepare to fail over to AWS and sever the connection with on-prem and rebuild a new standby server, rebuild a standby server that is already there and waiting for a backup to be restored to it and synced up with another DB2 instance within AWS. So that was the migration plan, that high-level migration plan that I had came up with and that we used with this specific customer. Our next stage was to build out these clusters, these HADR, these DB2 HADR clusters. And There's a lot of things that you need to think about. Obviously, your networking, your regions, VPCs, subnets, your primary and your secondary servers must be located in different availability zones in order to be highly available. You need to make sure your EC2s are well fitting. The specific customer was on virtual machines that had way too much resources. They weren't even using them. And so we had to scale down, and we made sure that the EC2s that they picked were going to be effectively used, and that money wasn't just going to be, thrown out the door for no specific reason. You also have to create your volumes, to figure out how many data volumes you're going to need in order to parallelize I/O, database volume, your Active Directory, your active logs, temporary space, your fail arc space, and I also used EFS, which is like NFS, which was a file system that was shared between both primary and standby. And the EFS file system was where all of our backups were stored and also where archive files were sent. And it was really great to have it shared amongst the primary and standby node because they were very easily accessed between each of the nodes in the cluster. And they were part of the same EFS security group. So when it came time to restore our standby server and restore a backup to our standby server, it was very easily accessible. And everything that was needed was easily accessible right at your fingertips because of that EFS directory. An S3 bucket was created. And the S3 bucket actually was used for many things for the automation. It was used to store the installation files for DB2. And it was used to automate the process between the primary and the standby server. When the primary server finished a certain number of steps, it would copy a file to a specific S3 folder. And the standby server was in a lock wait state, waiting for that file to be sent to that server. And as soon as the primary had sent it, the standby recognized that and continued processing. And in this way, we were able to set up HADR automatically because they were, in a way, doing this kind of dance between each other with the use of files being copied to S3. All of the files for cron job setup and any other files that the database team needed were also located in S3 buckets and part of the automation scripts that I had created. Of course, you need to figure out your security groups, your ports, what kind of services you're going to need to have on that cluster, IAM rules for your S3 bucket, policies for your EC2 instances, and then, of course, you're going to need to figure out installing and setting up your instances, so installing DB2 and setting up your instances, and syncing up your HADR clusters. And the last thing we did is setting up host names through Route 53 and giving them a host name that can be used instead of an IP address. So once you got to step 4, a lot of work has been done. And this kind of thing, actually, an Excel sheet should be created, and all the information that you did for dev, you're going to need to figure it out for every other HADR cluster that you are going to be creating for your customer. And you're going to have an Excel sheet that's just going to lay out all the different parameters and all the different environment changes for each of your clusters that you're going to create. So step 4 is automation scripting, the fun part, I think. I had to have everything automated, and I pushed automation. And a lot of the time was taken to automate the deployment of infrastructure and the setting up of these two clusters so that we could easily move through this migration because of this timeline, this timeline that we had to deal with. So if there was anything that was done in AWS, it needed to be put into Terraform. If there's anything that needed to be created, it was put into Terraform. All of the setup that was done on the servers was put into Bootstrap scripts, and they were very intelligent. Like I said, that they even set up the HADR cluster. They went so far as to setting up the cron jobs that needed to be there and laying out the directories the way that the database team liked it. It did as much as it could do. And this step here, for anything else, I'm just saying, whatever it is, automate it. Make it so that you have a few buttons to press and that everything is created and created correctly. Step 5 here is to deploy and test it. And you'll go through many deployments and testing over and over again because you're going to find out all these little errors. But eventually you will get there where everything is done right. And you'll be at the point where you'll test your HADR cluster. You'll have your failovers tested, your shutting down of the server and starting up of the server tested, and that everything with DB2 is perfect. I did run into one error I'd like to mention. Mounting my volumes was a problem. Every time I shut down the server and I restarted, the mounting of volumes had changed. And I needed to fix that. And so remember to just test shutting down your server and restarting it up again. And the solution for that issue was to make sure that you mount based on volume ID. And there are numerous blogs about how to do this within AWS as well. So once you are fully tested, you're going to want to restore a backup, like a dev backup from on-prem onto your AWS HADR cluster now. And so you'll take a backup from the on-premise database and you'll copy it to S3 or get it over to DB2 in AWS, and you're going to restore it on the new cluster that you created. Here is where you let the application team get at it. So now you're going to have data that's there, you're going to have grants that are there, you're going to have tables that are there, you just restored a database. And once that happens, you're going to have to work with the application team and make sure you go through their testing and fix any problems that they have. Once you are at stage 5 here, you are essentially home free for the rest of the project. Step 6 is syncing up our on-premise DB2 with AWS Gb2 Instance. So we're at the point now where we are ready to start our migration to AWS. What you got to do is you got to take your AWS HADR cluster and you're going to break it. And you're going to take one node and you are going to make a node or an instance, a DB2 instance in AWS. You're going to make it the standby server for your on-premise primary database. And you're going to make sure that that connection is available through VPN with the help of your networking team. So that the primary on-premise database server can connect and communicate with the DB2 standby instance in AWS. Once you have synced those up, sync those two clusters up, or those two instances up, syncing requires you to restore a newly created backup from on-prem to your standby database and rolling forward the logs. Once they are synced up, you are all ready to migrate, and you're going to be waiting for the rest of your team to be ready for the migration. When everyone is ready, you're going to do a live migration, and you're going to say, okay, it's time to fail over on-premise to AWS. You fail over DB2 to AWS, and the application team switches over, starts using your new primary DB2 server in AWS, and everything is working with your application, obviously, and it's time to sever all connection with on-premise, and to create a new HADR connection with the other DB2 instance that is already created within AWS. And so you take a backup of your AWS primary server, your primary database server on AWS, you back it up, and you restore it on the standby server within AWS, and then you resync HADR. And now the whole cluster is now created in AWS, and you're done. So join me on my next video where I take you through stage 2, which is moving through the rest of the environments, and a lot cleaner than this diagram and a lot less hectic than this diagram.